Okay. Good morning, guys. I'm gonna go over the 10A notes here and give you guys a few of the formulas and definitions and stuff, just to sort of talk about surface area. I'm sure this is something that we're familiar with um, from the past. Before we do that, I just want to just give ourselves a little bit of a refresher here if we want to use our 9G and 9G Part 2 notes to try those 4 warm-up problems out. Go ahead and do that at this time just to sort of get our minds loosey-goosey. It should be a fairly simple thing. And so as we go through talking about surface area here and volume as well, hopefully some of this stuff may make a little bit more sense to us as we go along. All right. So finding surface area. All right, surface area is exactly what it sounds like. Okay, we're finding up the area. We're finding the areas of all the surfaces, um, and we're going to add them up. Okay, we're adding up all the areas of each surface. Okay, to find a surface area, and all of our area stuff goes back to our Unit 9 notes. Most of it was on the 9A notes, I believe. The regular polygon stuff was, I believe, 9C, 9D, somewhere around there. Again, we may need to use some trig and stuff like that in order to find some apothems or some perimeters or something like that. But again, we still should have all of our Unit 9 notes to sort of go back and do that. The 5 shapes we're going to be looking at are prisms, cylinders, pyramids, cones, and spheres. All right. And I'm going to jump around a little bit here. I want to start here with surface area of a prism. Okay, we know a prism is just a box shape. Okay. And with prisms, there's a formula to find the surface area of prisms. I'm not particularly a fan of that formula. I think it's a little bit confusing. In prisms, I mean, there's just rectangles and then whatever shape the bases are. Okay. So the best thing to do here for prisms is find the area of each surface and then add them up. All right. Find the area of each surface and add them up. We could have, a triangular prism where, we have a triangle and another triangle over there, kind of like a Toblerone bar. We could have a rectangular prism or a square prism, which, we all know is sort of like a box. We could have a pentagonal prism where it's just a pentagon and another pentagon down there connected by a bunch of rectangles in the middle there. So anyway, that's what prisms are. Prisms are just basically box shaped type things, and then the lateral area of prisms are all rectangular. I'll sort of get to that in a minute, but again, the formula, there is a formula for prisms. I don't really like using the formula. If you want to look up the formula online and figure it out, that's cool. I think it's best to just find the area of each surface and add it up. It's just the simplest way. Okay. With that out of the way, the surface area of a 3D figure has 2 parts. Okay, there's 2 parts. There's the base or the bases, and the lateral area. All right, and the lateral area is just all the area that is between the 2 bases. Okay, so if we have a prism or a cylinder, there's 2 bases. Okay, the lateral area will consist of rectangular shapes. So whether we have like any kind of a prism, like we sort of talked about here, if let's say we have a square prism like this, okay, well, if this square is the base and then the square back here is the base, okay, all of this purple stuff right here, here, and then back over here and underneath there, it's rectangles. Okay, so basically in a prism, a rectangle is going to connect the base to another base. Okay, same thing if it's a cylinder, because a cylinder is just basically a circle prism if you think of it like that. So if we have a circle, right, and it comes to another circle kind of like this, I don't know, kind of that kind of thing right there. So we have a circle here, a circle there, okay, and then everything in the middle is sort of um, a rectangular shape. Okay, it's a rectangular shape. All right. All right. Next, for uh, pyramids and cones. Okay, pyramids and cones, there's one vertex and a vertex opposite the base. So the lateral area is triangular shape. So prisms and cylinders, 2 bases, the lateral area is a rectangle. pyramids and cones, there's one base. The lateral area is a triangle. Okay. So that's that. So we got prisms. So the best thing to do is find the area of each surface and add them up. It's not the only way, but in my experience, it's the best way. Okay. To find the surface area of a cylinder. Now, again, if we want to just find the area of each thing and add them up, we could find the area of each thing and add them up. Okay. So we know our two bases are circles. Okay. And so circle area is pi r squared. There's two of them. So 2 pi r squared takes care of that. All right. The lateral area of a cylinder is a rectangular shape. So if we have a cylinder, okay, if we have a cylinder, the lateral area is a rectangular shape. So all of this in between the two circles is a rectangular shape. Okay. The length of the rectangle is going to be the circumference of the circle. Okay, and the height of the rectangle is going to be the height of the cylinder. So that's the height of the thing there, and the length is the circumference of the circle. Okay, so the circumference we know is 2 pi r. Okay, or we can call it pi d if we want to, pi times diameter. Okay, and the height is the height. Okay, so to synthesize our formula here, the surface area for a cylinder is 2 pi r squared. That's our two bases, plus pi times diameter times height. I'm going to capitalize that h there too, by the way. It's the distance from base to base. Pi times diameter times height. Okay, so 2 pi r squared plus pi dh. Okay, really, if you wanted to sort of cut it into two things, we have pi dh is really the only thing that we have to sort of remember here. Okay, so the circumference, which is pi times diameter times height, is going to give us the lateral area here, which is this rectangular shape that wraps around the cylinder. Think of it as like the label on a can of soup or something like that. All right, and then 2 pi r squared, well, that's going to take care of our circle up top and our circle on the bottom. All right, moving on. So if we're going to find the surface area of the pyramid, we have to first find the area of the base shape. Okay, find the area of the base shape. The base shape could be any kind of polygon. So triangle, rectangle, square, pentagon, hexagon, you name it. Okay, so we got to find the area of the base shape, which again, go back to our 9A notes in order to figure those out if we need to. Okay, the lateral area consists of a bunch of triangles. So the lateral area is, base times height divided by 2 of all the different triangles, very much like perimeter apthon divided by 2. However, instead of doing them, base times height divided by 2 for all these different triangles, we can synthesize it. Okay, we can synthesize the lateral area formula into, the perimeter of the base times the slant height divided by 2. PL divided by 2, where P is the perimeter of the base shape. Okay, L is the slant height. Okay, not the same thing as the height of the figure. All right, so doing the perimeter times the slant height divided by 2. All right, so the surface area formula for a pyramid is going to be perimeter slant height divided by 2 plus the area of the base, whatever shape the base is. Okay. Just as an example, let me see if I can find another one of these things here. All right. So I don't know why this is written on here, but okay. So here we have a pyramid right here. So if we needed to, if we didn't have the slant height, we'd see the slant height is right here. This is 2.2. All right, let's just say hypothetically they gave us a height that was like this. Okay, a blue line going from the middle here up to the top there. That height is useless. Okay, in terms of finding surface area, that height is not the same thing as a slant height. Okay, what it does though is the height and the slant height make a little right triangle right there. So, in case they don't give us a slant height, which they may not in later things, and especially on some of these pre-AP problems on the bottom, if they just give us the height, then we can work to find a slant height if it's not already there. But in this case, the slant height's there. Okay. So if we're looking at a pyramid sort of from the ground level right here, okay, if we're looking like right at a pyramid from the ground level, this is the height, and the hypotenuse is the slant height. Okay. So we may need to do some Pythagorean theorem or something like that to figure out the slant height. That's sort of the worst case scenario. But oftentimes they'll give us a slant height. If not, all it is going to be, a squared plus b squared equals c squared in order to do that. Okay. Now a cone and a pyramid are pretty much the same thing. The cone has one base, which is a circle. That's pi r squared. Okay. The lateral area is a triangular shape with the circumference of the circle. Okay. With the base, being the circumference of the circle, and the height being the slant height of the cone. All right. So the circumference of a circle we know is 2 pi r. Okay. Slant height. Okay, so this is sort of like our base of a triangle. This is sort of our height of the triangle. Divided by 2, those things go away. Okay. So the lateral area of a cone is going to be, is 2 pi rl over 2, which becomes pi rl, excuse me. So the surface area for a cone, okay, we have the base, which is a circle, pi r squared, plus our lateral area, which is a triangle, pi times radius times the slant height. All right. So you have the rest. You have about 6 practice problems on this next page, or actually a little bit more than 6, about 9 practice problems on the next page, and then some more problems after that. We're missing the slant height here, and then we have some pre-AP questions on the bottom. So you can get going on those, and we'll talk about those questions a little bit later. Thank you, and have a great day.